Once we've collected remote sensing imagery, there's a lot of different interactive and kind of, manual ways to interpret the image. This shows some examples here. One of the ways that we could do it is we could just take the image, which would be the rectangle underneath, and we could break it into different categories just by kind of drawing lines through it. This might be where the farmland is. This might be where the forest is. This might be an urban area here. So we're just separating those into different areas manually, basically by digitizing on the screen where we see those boundaries to be. Another thing we might just do is if it's an aerial image of a parking lot, we might just count the number of cars. So we could just go ahead and count the number of ones. That would be something called enumeration. Sometimes we just use remote sensing imagery just to measure between 2 points. So we just want to see how far apart things are. Or we could expand that and measure an area by measuring the entire outline around something. And sometimes we just want to delineate something, like for example, if there was a oil spill, we might just want to delineate where the oil spill is in the image that we're looking at. So once again, some of this can be done just by digitizing lines or points onto a screen or just adding up what we see. But other times we might want to be a little more robust than that. And this is where we would use image classification. So the way that image classification works, as we'll see in this class, is that we start out with remote sensing imagery, which is shown here. The DN stand for digital numbers, and that's what these numbers of each pixel represents. And then we take those digital numbers and we compare them from one band of the remote sensing image to perhaps one or two other bands. In this case, this might be what was collected from the red portion of the electromagnetic spectrum, the green portion, and the blue portion. We see how all those numbers graph out, and we see where the clusters are. And based on those clusters, we might be able to assign them to different categories or classes. So in this example here, C is equal to rock, so all four of these pixels here, because of how their numbers plotted out, how the 180 and this number plotted out in three-dimensional space, it gets a value of C, as does its neighbors, and this one here. And then other ones plot out in a much different place. They might get a value of B and A, where B represents agriculture and A represents water. And in the end, we're able to take this classified image and we're able to draw a map with it, as is shown on this side here. It's a very simple method, but we can get things that look like this. They might not be so, there might be some kind of mixing of pixels where we get, in this case, some sparse vegetation right in the middle of what is otherwise agriculture or grassland. But we can easily see the types of patterns that this was able to break out. So that would be unsupervised image classification. We're just taking all the numbers associated with the different bands of the remote sensing image and we're seeing where they plot. But another type of thing we can do is supervised image classification. This is where we already, just by looking at the image, we already know what parts of the images are. For example, all of this dark blue area here is water. So we kind of sample just the pixels in this area here, so we already know what their values should be. And we say pixels that have values like this in the different bands of the remote sensing image are going to be assigned to water. And here, this is all agricultural. So pixels that have values like this are going to be assigned to agricultural. And then this up here is bare rock. So ones that have pixel values like that will be assigned to bare rock. We can see some places it's going to work well. Some places, well, I'm not sure if that's bare rock or agricultural in this area here. But it's going to do some sort of categorization. It's going to put those into different categories. And we're going to end up getting 3 different categories here where all pixels are assigned to one of those. And this is an example of what we would call a supervised image classification. The reason we're supervising it is because we're deciding on where we want these training areas to be. And then we're deciding other pixels that look the same as the ones in this training area, they're going to be assigned to the same class or category. And this would be an example here. So we start out with the raw imagery over here. These colors just represent what colors are seen with their sensors. They're not categorized or classified yet. But then we take these various training areas, and then in the end we get something that looks very similar. But now we have these classes or categories that we've broken the image into, so that we can say, for example, maybe all of this in dark green is a forested area, and all the stuff in dark blue is now a river or the water. So these classifications can be quite powerful in assigning land cover or land use categories to very large areas, and in a systematic way that doesn't involve just kind of tracing things out on the screen and maybe some user error